I think we can start now. So good afternoon, everybody. So last time I started to explain output compare. And as I told you, the main idea of output compare is, you have a register CCR, you have the timer or the counter, as you see here, this is the counter here, okay? Once the counter is equal to CCR, two things here, and also here, and also here. Every time the counter is equal to CCR, two things should happen, two things. Number one, interrupt is triggered, that's number one. Number two, action can be taken on the pin. And the action is something you can program. For example, if I can select the action for toggle, you are gonna get a signal like this one. So I explained this one last time. And this is one way we can do it to generate signals this way, okay? And first, when I explained it, actually, I don't need the interrupt, so I don't need to do anything in the here, the way I did it. Okay, so as you see here, every time CCR is equal to the counter, the pin is toggled, and I don't need to use the interrupt in this case, so I don't need it, okay? So this was the first program I explained last time. The second program, that's what I'm going to teach now, is the second program is periodic interrupts. As I explained in chapter 4, we have only one system tech. So this is the only one we have to generate periodic interrupts. What if in my project I need to 3 or 4 systems to generate interrupts? Okay, so here you can use, although this is not the main functionality for output compare, but you can use output compare to generate interrupts, periodic interrupts, exactly similar to system tech. Okay, what is interesting here is how many channels we have in total. As I told you last time, for one timer we have 40 channels. For the other 2 timer we have 2 and 2. So in total I have 80 channels. Is that okay? Maybe in your project, that's what I want to say. Maybe in your project or your application, maybe I don't need to use all of them as input capture or output compare. Okay, in this case, you can use some of them similar to system tech to generate periodic interrupts. Okay, and you can tell here already there is periodic interrupts, so the concept is not far. Why the concept is not far? Because that's what I said here. So what happens here? Every time CCR equal to the count, interrupt is triggered here. You got what I'm saying? So I can have interrupt here, I can have interrupt here, I can have interrupt here. By this way, I can have periodic interrupts. And the time from here to here is the same like the time from here to here, and also the time from here to. By this way, so it's already there. You understand what I'm saying? So, but in this case, I don't care about the pin, so I'm not going to use the pin. Okay, because I'm not generating a signal. I just want to get periodic interrupts. Okay. So. And that's what I explained also last time. However, there is a small issue here I'm going to fix, okay? So what is the problem here? The problem is that, as you see here, the timeout is fixed. Timeout is fixed. It has to be from here to here. Even if you change CCR, as I explained last time, as I told you last time, so even if you change CRR, for example, if you make CCR this way, also the timeout is going to be from here to here. So regardless the value of CCR, you are going to have a fixed timeout, and this is the timeout is going to be this value 1 plus ARR times 1 over the clock. Okay, and this time we made it 1 millisecond last time. Okay, so now what I'm gonna, that's what I explained last time. So I explained last time how can we generate periodic interrupts this way, and it was, for example, if I make this one 999. So I can have interrupts every 1 second. So here, from here to 1 second, 1 second. Okay. So what I'm going to do right now is I'm going to make a very little modification to the program I explained last time, so that I'm going to have more flexibility for the timeout. I'm going to have more flexibility for the timeout. I can change it easily. You know how? I'm going to tell you how. So what I did in the last program, I did not change CCR. But you can change CCR. So what can happen is that if I have interrupt here and I move CCR to here, for example, I say if CCR, for example, has 70, the number 70, and then in this interrupt, I'm gonna say, I'm gonna put a different value in CCR. For example, I'm gonna say 100. So what's gonna happen? Another interrupt is gonna come here. You got what I'm saying? So that's what I didn't do last time. I'm gonna modify the program I taught last time. So again, let me summarize what I said. What I said last time, I did not change ZCR. That's why we had it was not easy to change the timeout. Okay, so the timeout has to be from here, and here to here, and so on. Okay, now I'm gonna do a little bit modification to the program I taught last time, so that I can have more flexibility for the timeout. Okay, for example, as you see here, the way I programmed the timer here, it's gonna count one clock every 1 millisecond. Okay, so what's gonna happen, as you see here, if CCR equal 50, okay, so that means I'm gonna have interrupt here. If I in the interrupt subroutine, if I say that CCR now equal 100, what it means? It means the next interrupt is gonna be after 50 counts, which means every count 1 millisecond. That means next one is gonna be after 50 milliseconds. You got what I'm saying? So let me summarize what I said. What I said, guys, is that by this way, it's going to be very easy to change the timeout. Okay, so all what I'm going to do in the interrupt subroutine, I'm going to say, as you see here, I'm going to write something like that. CCR equal to CNT. CNT is the current count, whatever the count is, the current count plus timeout. Okay, that means because you're changing CCR, so that means the next interrupt is going to be after 50 milliseconds. If you needed 51 milliseconds, just make it 51. That's what I'm saying. In this program, it's going to be very easy to do the timeout. You got what I'm saying? If you need it to be 20 milliseconds, just put here 20. If you want to make it 500, just put here 500. Is that okay? So as you will see, I'm not going to teach a new program. It's exactly the same program I did before, but I'm going to add here again. What I did here, guys, I did not change CCR. CCR was 500 and it was fixed. Okay. That is why here I had interrupts every 1 second. Okay. Now, no, I'm telling you, I can make this program more flexible by writing some command here to set to change the CCR. Is that okay? However, there is a small trick here. What is the small trick? Look here, guys. I cannot just keep using this one this way. Otherwise, there will be a mistake. Okay. For example, if I come here, because keep in mind your maximum is 1,000. Okay, so if you add this one plus this one, and the result was 1,050, for sure this one is not going to go to 1,050. You got what I'm saying? So if you put CCR here, you are not going to have any interrupts, no interrupts, because the count will never equal to CCR. That is why after I add 50, I have to check if it is more than ARR, so I have to subtract AR so that I can bring it here. You got what I'm saying? So I have to bring it here. Okay. So again, after you add the timeout, if the total is greater than ARR, I have to subtract AR. For example, I want to count 50. Okay. Maybe you are here, so I'm gonna count here 25 and then 25 from here. Okay. So by this way, I'm gonna say the new CCR should be 25, not 1,050. Okay, it's not 1,050. Okay, because it's not going to go to 1,000. So that's exactly what I did. So I'm going to choose a program here, guys. Again, this program is identical to the previous program. All what I did, I just added this part in the interrupt subroutine. I just added this part here, only this one. Okay, so as you see here, what I did, I said here, this is the count plus timeout, whatever your timeout is. Okay, and then as I told you, so that means and again, I told you, now I'm going to check to ARR. If it is greater than ARR, so I'm going to subtract ARR. Is that okay? And then at the very end, I'm going to put it in CCR. Okay, very easy. And also you can have flexibility in the calculation of the timeout. Okay, guys. This is okay. What about this part you put here? Okay, you can see here, I commented this part. This is if it is counting down. So if it is counting down, in this case, I'm going to subtract CCR, not add CCR. Sorry, I'm gonna subtract time out. So as you see here, I give you the two cases. If you are counting up, if it is up, so if CCR is here, so for example, every time I'm gonna add time out, okay? But if it's counting down, so every time I'm gonna subtract, okay, as you see here. So actually, yeah, so you can use this part if the timer is counting up, and you can use this part if the counter is counting down. Any questions here? You understand what I did? So here we can have flexibility here. Whatever the value of time out you have, every time you can just add it here. You understand what I'm saying? So you have flexibility here to set the time out. Okay. I'm gonna leave this program to the end if I have time. Okay. Now I'm gonna move to this program. So what I did last time, guys, now this program is more general than what I did before. Okay, so let me just remind you what I did before. What I did before, guys, in this program, yeah, this was the first program I explained last time. Here in this program, I did not use interrupts. Yeah, so here in this program, if you remember, that's what I explained last time. I did not use interrupts. All what you used, just toggle. Every time CCR equal, you are gonna toggle. By this way, you can generate a signal, 50% duty cycle in this case, as shown here. Yeah, so here the period here is going to be this value, double this value as you see here, and it's going to be 50% duty cycle, as I explained last time. Because all what I'm going to do, I'm going to just toggle here and toggle here, toggle here and toggle here, and I don't use interrupts. As I told last time, guys, you can use the timer in different ways. So here I use the timer this way to generate these signals. I'm going to show you right now. And to generate this signal, I did not need interrupts. Okay, so I'm going to show you right now. Okay, so if I use interrupts, can I make something like more general than what I have here? Okay, what do you mean by more general? More general means I should have more flexibility about the duty cycle. I should have more flexibility about the frequency. You got what I'm saying? That means, for example, I can say I need a signal to be something like that. Here, 50 counts. Here, 60 counts. You understand what I'm saying? That's what I mean by flexibility. So it's going to be more general. Okay. Here you don't have, for sure, you don't have this flexibility because you just count on the toggle. Okay. So that's what I'm going to do in the coming program, and in the coming, so this program is more general. You can decide how much is the time here in number of counts, how much is the time here in number of counts. Okay, by this way you can generate any signal with any frequency and also with any duty cycle. So it has much more flexibility than what I did before. Okay, so now this program needs two numbers from you, two numbers. One number, how many counts here and how many counts here. By this way, you can have full control on the frequency you want to generate. Also in the duty cycle, you can have something like that. You can have something like that. You can generate whatever you want to do. Okay. So I'm gonna show you how this can be done, how it can be done. Okay. And when I explain it, I'm gonna use the same idea I have just used right now when I change it CCR. When I change it CCR. So what I'm gonna do, listen to me. What I'm gonna do, guys, is, for example, if I want to generate signal like this one, just any numbers. For example, this one is 100 counts. And this one, for example, 70 counts, for example. Okay. Remember, every time there is a toggle, I have interrupt here. This time I'm going to use the interrupt. Also, I have another interrupt here. Okay. What I'm going to do right now to generate this general signal, what I'm going to do is I'm going to manipulate CCR. I'm going to change the CCR because every time the counter is equal to CCR, there is a toggle. Okay. So what I'm going to do in this interrupt, I'm going to set the new CCR. I'm going to say CCR should equal CNT, which is the current count, plus 100. So that after 100, so you got what I'm saying? So that's what I'm going to write in the interrupt subroutine here. I'm going to say after you count 100 more counts, please toggle. That's what they're having here. Toggle, okay, and interrupt. In this interrupt, I'm going to say the next one should be after 70. You got what I'm saying? So this is the modification I'm going to do so that I can generate. So all what I need. So in this case, guys, all what I have to do is that to generate something general like this one, here, I have to say here, I have to manipulate CCR. Again, so it's not what I did before. Okay, just to make it very clear. What I did before, CCR was fixed. CCR was fixed. Because it was fixed, there was one interrupt here, one interrupt here, one interrupt here. Frequency was fixed. I got 50% to do the cycle. I didn't have too much control on the frequency or on the duty cycle. Now, no, I will change it. So what's going to happen is that if here, for example, I'm going to say once in the interrupt here, I'm going to say, I'm going to change, I'm going to say the new CCR here. Okay, so that, okay, so that, or for example, I'm going to say it here. Okay, so that here you are going to toggle here. Okay, and so on. So you are going to change CCR in the interrupt subroutine. So this one is more general. I started with the basic, with the easy way without interrupts, and now I little bit complicated it. So all what I need to know, guys, so again, I have periodic interrupts. So once I receive interrupt, I have to know if this interrupt is here or here. Okay, because if the interrupt is here, that means I have to say TCC should equal TCNT plus high time. However, if it is here, I have to say TCC equal, sorry, it's not TCC, it's R, sorry, CCR, okay? CCR, here also, CCR, the register, the value in the register should equal TCNT plus low time. Is that okay? So I have to know, you want to toggle after this time or you want to toggle after this time. So as you see right now, I need to know if I'm here or I'm here. How can you know if you are here or here? Very simple. I'm going to use a variable. I'm going to use a variable. This variable should take two values. Okay. For example, 0 and 1. 0 for one case, 1 for the other case. Okay. So that's exactly what I did. So I'm going to show you what I did. So here in the what I did in the interrupt subroutine, as you see here, guys, I'm going to use a variable. It's going to tell me high or low, just to tell me if the signal right now is high or low. Okay. So what I'm going to do here, as we see, if the signal is 0, so 0 is one case, 1 is another case. If it's 0, I'm going to make it 1. If it is 1, I'm going to make it 0, as you see here. So every time, so that means, for example, if here it is 0, it's going to become 1, 0, 1, 0, 1, because every interrupt, I'm going to switch from one value to another, as you see here. Okay. And then after that, very simple, look, after that, what I did, if it is 0, so I'm going to, if 0 means, so now we are here, and now I need to set the time for the low, That's what I said. So I said here, temp should equal the count plus low time. However, if this variable is 1, so it's going to be, I'm going to add high time. So now you have 2 times. Okay, 1 for the high, 1 for the low. Okay. And again, if the value greater than ARR, you have to remove the ARR, and finally you have to put it in CCR. Any questions? You understand what I did, guys? So again, in the beginning, I started with a very simple program. In this simple program, I fixed CCR. So I did not change CCR. Okay, so CCR was fixed this way. That is why I had this kind of signal. I told you this signal, I don't have too much flexibility here, because this one always is going to be 50% duty cycle. Okay. Also, the frequency is going to be this way. Okay. So, and now I told you, no, I'm going to complicate it more by using interrupts. Okay. So here I didn't use interrupts. So what I did is that, for example, here in the high, I want to make it like 50 counts. Just an example. Here, I'm going to make it 70 counts. So very simple. All what I did in the interrupt subroutine, I'm gonna move. For here, because it's counting down. Okay, let's have counting up. Okay, it's the same thing. Counting down, you have to subtract. You don't add. Okay, so here, so for example, here, if I come here, I have interrupt. So all what I'm gonna say, CCR is a new CCR here, so that you toggle after this time here. Okay, same thing here. I'm gonna have another interrupt. I'm gonna say the new CCR here, so that you toggle after this one. Anyway, by this way you can generate. You generate signal with any frequency, because you have a full control. You can control how big, how long is this time, and how long is this time. Any questions? Again, you have all the programs. I tested all of them. I connected a scope and I looked at the signal, make sure everything is okay. They are working. Okay. The next thing I want to teach here, guys, we call it pulse pulse width modulation. Okay, if you remember, if I go back here, one of the modes of output compare was the pulse width modulation. So here, let me go back to show what I mean exactly. So yeah, here I told you when it is output compare, when you use output compare, you can use any one of these modes. So we mainly until now we used to toggle. That means we're going every time CCR equal to the count, you want the bin to toggle. So what I'm going to do right now, we have two more modes here, or for pulse width modulation. Pulse width modulation mode 1, pulse width modulation mode 2. Okay. So again, what is pulse width modulation? Very simple. Pulse width modulation, just one mode here. One mode is going to be used to generate a wave signal. Okay. But the main advantage, but here in pulse width modulation, is going to be too easy, very easy to change the duty cycle. Okay, because in many applications I need to do that. I want to generate a signal with different duty cycle. Okay, so it's going to be easy to again. Okay, what about programming? Nothing is new. Everything I did before, I'm going to do it right now. The only difference is that when I selected the mode before, there was 3. Yeah, as you see here. So here, what I'm saying, when you select the mode, in this register CCMR1, okay, there are 3 bits for each channel. So channel 1 has 3 bits, channel 2 has 3 bits, channel 3 has 3 bits, and also channel 4 has 3 bits. So okay, so what I did before, in the 3 bits, I put 0, 1, 1. Okay, so what I'm gonna do right now, I'm gonna just put 1, 1, 0 or 1, 1, 1. That's it. Okay, but the signal we are gonna generate is gonna be somehow different. How? I'm gonna tell you now how. Okay. So again, this is just one mode to generate a signal. Okay, we call it pulse width modulation. But as you will see right now, it may be just very easy to generate, to change the duty cycle, as you will see right now. Okay, so I'm going to show you now. As you see here, look here, guys. So here, as I told you, we have 2 modes, mode 2 or mode 1. This is mode 2. Okay, I'm going to tell you what is the difference between mode 2 and mode 1 for pulse width modulation. But for if you wanna for initialization, you have 2 different numbers, as you see here. So this number is for pulse width modulation mode 1. This number is for mode 2. That's it. That's easy. So just in the initialization, you have to use this number or you have to use this number. That's it. But how is it different? How mode 1 is different from mode 2? And how they work? Okay, and how the signal we are going to generate here is different from what we did before. That's what I'm going to elaborate right now. Okay, so yeah. So here, guys, in pulse width modulation here, if we use it mode 2, as you see here, so how it works, I'm going to tell you how it works. Look here, guys. Initially, as you see, look at the figure here. Initially, it is 0. Okay. When CCR is equal to the count, is gonna become high. Okay. And then always here is gonna become low. Always, all the time. That's how it works. This is different from what we had before. What we had before, we had a toggle here and we had a toggle here. But pulse width modulation is different, doesn't work this way. In pulse width modulation, always this here is going to be 0 here. Always we're going to have 0. Is that okay? And this one here is going to be move from 0 to high. Okay, guys. So this is how. So if you look at the signal we generated here, the signal, the frequency of the frequency is going to be similar to the frequency of the signal we have here. Okay, so so the frequency, yeah, it's going to be the clock frequency divided by ARR plus 1. Okay, this is not the attractive point. Well, the attractive point is you can easily change the duty cycle. Very easy. All what you have to do without even interrupts, you don't need interrupts. All what you have to do is that just to change the CCR. So if I put, as you see here, if I put CCR this way, I'm gonna get this signal. Okay. If I lower CCR this way, I'm gonna get this signal. So as you lower, as you see here, compare these 2 figures together, you can see as you lower CCR, the T on is gonna get bigger. T on is gonna get bigger. Okay. So the average frequency here, sorry, the average voltage is gonna be higher. Here is the average voltage is V divided by 6. Here V divided by 2. And I told you before, there are some applications I can control the load by changing the voltage, by changing the duty cycle. Okay, guys, so let me tell you that. So now you can tell from these two figures how it works. Okay, all what you need, and even you don't need interrupts. All what you have to do just to change the CCR here, so that by changing CCR, you can easily change the duty cycle. You can see the T on, the time for the on or the time for high is actually the count from here to here, which is ARR minus CCR. So how many counts here? Okay. So now I have a formula. If you are in mode 2, which is this case, so actually the duty cycle is going to be 1 minus CCR divided by ARR plus 1. That's it. Okay. So all what you have to do, guys, here, just very easy. You can exchange. You are going to get the same frequency. The only thing that can change the frequency is ARR. Okay. If you want to change the duty cycle, you can keep ARR and change CCR to change the duty cycle. Very easy. Just register. By changing this register, by changing the number in this register, you can get different duty cycle. Okay. Now this is for mode 2. What about mode 1? Mode 1 is identical to mode 2, but just flip the signal. That means this one is going to be high and this one is going to be low. That's it. So mode 1 is similar to mode 2, but just initially it is high, and when it is equal, it's going to go to low. Just flip the signal. Any questions? Because you flip the signal, so the duty cycle, because you flip the signal this way, so the duty cycle is going to be this part over the total. The total is going to be ARR plus 1. Okay, and this part you have to count from here to here until CCR. So it's going to be CCR divided by ARR plus 1. Okay, guys. Any questions? This slide is very important because programming-wise, nothing is new programming-wise. What I did here, exactly same thing what I did before. The only difference, there are 3 bits. Instead of putting, I'm going to put a different number. That's it. Okay. So here, if you want to use the timer to count up and down, you are going to get a signal this way. This is mode 1 and this is mode 2. Mode 2 this way. You can see there is a difference between this one and the previous one. The difference is that in the frequency here is going to be, look, the frequency here is going to be half, because here the frequency is going to be similar to this time. However, here, because you count up and down, so the frequency here is going to be from here to here, which is double. Okay, so that's why you see here. So here again, if the timer is counting up and down this way, everything is the same. Everything is the same, except you can get lower frequency because the time can be longer time. Here this was the frequency. Okay, here also this was the frequency, or this is the period for the frequency. Now you can get a bigger time. Everything almost is the same. Okay. So here, that's what I'm telling you here, guys. I made, again, I made this program. So this program, I'm going to use pulse width modulation for PB0. You remember PB0 has an LED. Okay. So by changing the duty cycle, you can just run it and just change the number. You will see, for example, if the duty cycle 50%, you will see the time of on is similar to the time of off. Okay. Or you can make the duty cycle, for example, 30%. It's going to be more on, okay, less on than off, and so on. So you can easily even see it, or it's better, you can connect the scope and you can see it. That's what I did. Okay, guys. So all what you have to do is that just as the 3 bits I told you. So everything is similar to what I explained to you before. The only difference here is just the 3 bits. Okay. So here, yeah, for example, if you want to use here, this case has to be 1 1 1 1. Okay, so you can use this instruction to put 1 1 1. Okay, for also you can use this one here for, okay, so the other case here, this one has to be 1 1 0. So here I did it this way, 1 1 0. Anyways, it should be easy to see this way. Okay. Also for counting, you can use this one if you want to count up. You can use this one if you want to count down. This one for up and down, we call it aligned counting. Okay. So I don't need to explain the program. Everything here is similar to what I explained to you before. Okay. Based on that, I generated several programs. All of them are the same. I just changed it. I did small changes. For example, you have this one here, but here we are counting up. Okay. And we are going to use mode 1. Here I used mode 2. So actually, if you see these two programs, they are exactly the same. We use counting up, but instead of instead of mode 1, okay, I made instead this one is mode 2, and I used this one for mode 1. Okay, same thing here. These two are the same, but counting down. These two are the same, aligned counting, aligned counting up and down. Okay, and I checked them and they are working. Any questions? Okay, so now here I don't use the interrupts. Here I don't use the interrupts. So again, look what I did so far, guys. Just I don't want to be confused. Number one, in the very beginning, I explained a very simple program without interrupts. Every time here, toggle, and I didn't use interrupts. I got this signal. Okay, this program number one. Program number two, I told you this one may not be too good because we don't have a lot of flexibility. So I explained another program here. In this program, I'm going to use, I used interrupts and I changed the CCR, okay? So that now you have two numbers. Yeah, you have two numbers, high and low. These two numbers are number of counts. So how big, how long you need this time in number of counts? How long this one in number of counts? Okay, and just use them in the program, okay? But here you need to use interrupt. So this is the second way I generated signals. The third way I explained it using pulse width modulation, and in this case, no interrupts. I didn't use, I don't need to use interrupts here, okay? But again, as you see here, the frequency, the good thing here, you can easily change is by changing CCR, you can easily change the duty cycle, okay? Again, nothing is new, just you need to change the initialization, okay? And I made it very clear here. Instead of using this, this is for mode 2, and this is for mode 1, and this is for counting up, down, okay? By the way, I want to tell you something here, just for your definition, or I just want to bring this one to your attention. If we use, this one is actually mode 1. So if you use mode 1, in mode 1, we call it left edge aligned signal. Listen to me. Nothing is new. I want to give you three definitions now. The first definition is that if you use mode 1 actually is called left edge aligned. Why? Because the signal, as you see here, the signal is left aligned. So if you look at the signal you are going to generate, as you see here, it's just left aligned. Okay, as you see here. If you use mode 2, it's gonna be, yeah. So here, I am using mode 2, so the signal becomes right aligned, as you see here. So if you look at the signal, again, it's not a big deal, but I just want to tell you, sometimes in some applications, I want the signal to be right aligned or left aligned, okay, or center aligned. I just want you to understand what is the difference, okay? So the difference, as you see here, is that left, as you see here, this one, the signal is going to be left aligned. Here, right aligned, okay? This is here, all what you have to do, just use mode 2. Mode 2 is going to generate a signal that's right aligned. Mode 1 is going to be left aligned. If you use the central, yeah, this one is called central aligned. So this is if you count up and you can count down, okay? Why it is called central aligned? Because if you look at the signal, this is the signal you are going to get. So the signal, you can see the signal is centered. Okay, it's not shifted to the right or left, center. Anyway, just this is just definitions. Okay, again, nothing is new. Okay, so if you use mode 1 or mode 2, or you use center aligned, just you should, I want you to know the definition, what it means. If you see it somewhere, for example, in certain applications, the signal has to be left aligned or right aligned or center aligned. So you should know the difference. Okay, any questions? Again, so what I explained here, guys, for the timer system, I'm going to use the timer system to do one of two things: output compare or input cache. Output compare is used to generate a signal efficiently. Okay, and you can tell why it is efficiently, because I explained to two programs. I don't even need interrupts in the two programs. You got what I'm saying? Once you set the hardware can generate the signal. It's not get after the initialization, we're going to take 0 time from the microcontroller. Very interesting, right? And there was another program we should have periodic interrupts. Okay, here when we generate, this may not be, this may be disadvantage here. And although this one is interesting because here you can generate a general signal for any duty cycle, for any frequency, because you have a full control on the time here. It looks interesting. However, keep in mind, there is a small disadvantage here. The small disadvantage, I'm gonna take some time from the processor in the interrupt here. I'm gonna take some time from the processor for the time here, okay? To serve the interrupts here, okay? To serve interrupts, that's it. So this may be a small disadvantage here, for sure. If you have the choice, if you have to choose, for sure, it would be better if you generate a signal without interrupts. You get what I'm saying? It would be better, because now the processor is gonna be, you're not gonna take any time after the initialization. You're not gonna take any time from the processor. Now, so this is everything about output compare. Okay, so we generate signal in different ways. Okay, very interesting. So now I'm gonna explain input capture. And I told you for input capture, how input capture is used. Input capture is going to be used if you want to measure time. That's what I made it clear last time. So measure time. So for example, here, for example, if you have here, yeah, for example, if I have a signal like this one, I want to measure the time from here to here. Is that okay? Or I want to measure the time from here to here. Okay, so I just want to measure the time. So in this case, you can use input capture. Okay, guys. So I'm going to explain now how can you use input capture to measure time. Okay, but before I do that, listen to me. Output compare is used. Okay, the main functionality of output compare is to generate signal. But also I can use output compare, okay, to have periodic interrupts like system tick. You got what I'm saying? Now, same thing for input capture. And the main functionality for input capture is measuring time. However, I can also use input capture similar to the external interrupts. Okay? Actually, I'm going to explain this program, how because I'm going to build on this program. So this program, I'm not measuring any time. I'm going to use input capture similar to external interrupt. However, I want to tell you, this one, it may not be very attractive comparing to using output compare like system tick. You know why? I'm going to tell you why. Because we have only one system tick. Okay, so I have only one system to generate periodic interrupts. Okay, that's why it would be very useful if I learn or if you can use output compare similar to system tick, because now you can have eight similar to system tick. Is that okay? However, for external interrupts, we already have 16. So based on what I explained in chapter 3, we already have 16 of them. Okay, so we made it. This one may not be very attractive, but anyway. So, but let me remind you how input capture works before we started. Okay, so I'm gonna go back some slides to show you how it works and how it is different from output compare. Okay. Yeah. Again, in case of output compare, guys, as I told you, we have a register CCR. Every time the counter is equal to CCR, two things should happen. Number one, interrupt is triggered. Number two, action is taken in the bin. Okay, this is output compare. In case of input capture, it is different. What happens in input capture, we have a bin this way, and we have a signal this way. Okay, and then you can program what do you want to capture. You want to capture only rising, only falling, or you want to capture both. For example, let's make it easy. I want to capture only rising. So I want every rising, I want to capture. How it works, how input capture works, I'm going to tell you how. Every time there is an rising edge, this is if I want to capture rising. Every time there is a rising edge, two things are going to happen. Two things. Number one, interrupt is triggered, so there is an interrupt here. Number two, the count of this event is going to be stored in CCR. And then you can take it from CCR. Okay, so actually I think I have a very nice. So again, there is big difference between CCR here and the CCR in case of output compare. In case of output compare, you write to CCR because you wanna toggle the signal off at a certain value of CCR. But now, this is like a timestamp. When an event comes, when there is an event, so the time is going to be stored in CCR. Okay, this time you are going to read CCR, not write to CCR, because this is the time. Okay, and I think I have a very nice figure here. Yeah, look, for example, guys, and this is a trivial case. For sure I'm going to complicate it. For example, guys, look here. I want to measure the time from here to here. Okay, how input capture can do it? I'm going to tell you. What happens is that when there is a falling edge, again, two things are going to happen. Number one, interrupt is triggered. There is an interrupt is triggered. Number two, the count, which is 30, is going to be stored in CCR. The count at this moment was 30. Okay, it's going to be stored in CCR. In the interrupt subroutine, you have to empty CCR. You have to empty. So this timestamp, I have to store it somewhere else. You get what I'm saying? Why you have to store it somewhere else? Because when the second one comes, the value of the counter is going to also be stored in CCR. You got what I'm saying? So this is exactly what should happen. What should happen is that, guys, look here, guys. We're going to have one interrupt here. In this interrupt, I'm going to take 30, which is stored in CCR. I have to store it somewhere in a variable, in a memory variable. Is that okay? So that I need to empty CCR because CCR is going to hold the new value. Okay. And then at this moment, this one also another interrupt here. And then I'm going to take this value. So here I have this one, I'm going to call it H1. This is the timestamp for H1. This is the timestamp for H2. Once you have the time here and once you have the time here, for sure, as you will see right now, I can do mathematical operation, simple mathematical operation to measure the time from here to here in number of counts. I want to know how many times the timer counted from here to here. Is that okay? Once you have the timestamp, or once you have the count here, and once you have the count here, I'm going to show you how can you count it. Okay. Someone can tell me, you don't need to show us. Just use subtraction. Just subtract. You understand? Is that right? So if it was here it was a 63. Here it was 30. Okay, just subtract. That means from here to here, it counted 33 times. 33 counts from here to here. Is that okay? The answer is no. It may work in some cases this way. In some cases, it's not going to work. It's not as easy as like this one. Why? Because simply, what if the signal, for example, here, look here, guys. Okay, we have one edge here, and then I got the second edge here. You got what I'm saying? So it's not. So this is a very easy way straightforward. That's not always like this one. So now I need a general formula. I'm going to explain later how. But anyway, so let me now. Okay. So in the first program here, guys, I'm going to explain how can I use. I don't care about the time. I'm not measuring anything. Okay. Just every time there is an event. And this event, you can program it, either rising, falling, whatever. Okay, you are gonna trigger interrupt, and then you can, similar to external interrupt. You got what I'm saying? In the interrupt, you can do whatever you want to. Okay, so this is the first program. In the second program, I'm gonna use exactly everything here, but now I'm gonna show you how can we measure time. So I started with a very simple program. In this program, I'm gonna use input capture similar to external. Okay. Yeah, here. So as you see here, guys, all what I did this function here, okay, to do the initialization. And if you look at the initialization, it's exactly similar to what I did before, is exactly same thing. However, so this is the initialization here. So similar to what we did before, you need to set for the pin, that's exactly what I did before. You have to do this one. Also, this one, please don't select the input. This is very naive. I said before, I'm not going to select input or output here, okay? Because I'm going to use alternate function, okay? Because we are using here alternate function, which is input capture. Input capture is alternate function. So this is similar to what we did in output compare. So we'll see here the configuration is going to be similar to output compare except two places. Okay, so where are the, I'm going to tell you where. So this is similar to what we did in output compare. This even similar to what we did in output compare. The only difference comparing to what we did in output compare is, I'm going to show here so this one also similar to what we did before. This one is similar to what we did before. Yeah, here the difference is here. Look here, guys. Here, here I have to select this one is going to be different from what we did before. Okay, what we did before in this register, we selected output compare. Here I'm going to select input capture. What I'm saying. So if you look at the configuration I did in output compare, what I'm doing here is exactly the same, but this one is going to be different because this register, using this register, you can tell the processor this is channel 3, channel 2. This is channel. You want to use it input capture or you want to use it output compare. Is that okay? So this is different from what we did before. Also, this one also is different here. So here in this register, as I explained to you before, there is a slide already explained in details before. There are here you can select what do you want to capture. You want to capture rising. 0, 0 should give you rising. I'm going to go back to show you. So here, yeah, here I guess, yeah. Look here, guys. So here every channel has 2 bits, as you see here. Okay. So I did not do that in output compare because you should not do this one in output compare. In output compare, you don't capture anything. Okay. Anyway, so here you can, if you put 0, 0, you are going to capture rising. If you put 0, 1, you are going to capture falling. If you put 1, 1, you can capture both. These are all the options we have. Okay. For example, I'm going to capture only rising. This is something you can control easily using these 2 bits. Anyway, and then, okay, everything else is the same. You enable interrupts, everything else is the same. Once you do the initialization this way, guys, what's going to happen after you finish the initialization? Here, all what you need, you just to call this function to do initialization. Once you do that, you are going to have interrupt every time the pin there is a rising or rising edge on the pin here, you are going to trigger this interrupt, and then you can do whatever. So what I did here, guys, what I did here, I just toggle one LED. So, and here I selected BA6. For sure you can select, we have several any other pins, but here I intentionally selected BA6 because BA6 is actually connected to switch 5. So if you run this program at home, what you will see is that every time you press switch 5, you trigger interrupt, and then you are gonna toggle the LED. So if you run this one at home, you will see every time you press the button, okay, you are gonna actually trigger interrupts, and here in the interrupt subroutine, I toggle the LED just to make sure it's working. Okay, guys, any questions? Okay, here I don't measure time. Now let's come. Now I want to measure time. So what you are gonna do? Okay, what I'm gonna do, guys? The initialization will be the same. I'm not gonna change the initialization here. So what's gonna happen here? I'm gonna have 2 interrupts. One interrupt here and one interrupt here. Is that okay? So in this interrupt subroutine, I have for sure here whatever CCR, I'm gonna store it in a memory variable. I'm gonna call it, for example, H1. This is the time for H1, and this one should be the time for H2. So if you have this time and you have this time, okay, I'm gonna show you now. I'm gonna give you a formula to count how many times, or how much, how long is the time from here to here. Okay, guys. Okay, now I told you we should not only subtract. Sometimes it's more complicated than that. Okay, so that's what I'm saying here. I'm gonna show, it's just a very simple formula, but I just want to explain it so that you can understand it. Okay, so that's what I'm saying here, guys. This is a very naive case or very simple case. It can happen, but it's not guaranteed it's going to happen all the time. It's not guaranteed. Okay, so for example, if I rising edge comes here and also the second rising edge comes here, okay, in this case you can just subtract. This is a very easy case. You can subtract the 2 numbers in order to get the time in number of counts. Is that okay? But it's not guaranteed to be this way. Okay, so it can happen something else. So That's why I'm going to give you a general formula right now. Okay. What can happen is that, look here, guys, for example, okay, so I got the first one here. Okay, or for example, yeah. So for example, H1 here, H1, I got it here. Okay, guys, at number 50. Okay. And then we count it until here, and then I'm going to count until here, and then we are going to end here, for example, at 100. You got what I'm saying? So you can simply say it's going to be 100 minus 50. It's not true, right? Because what happened, you counted from 50 until ARR, and then go to 0, count another time to ARR, come 0, and then you counted 100. You got what I'm saying? So how can we count? How you, in this case, if you have a case like this one, how, given the information we have, I have 50, I have this one 50, also I have 100. Okay, can I count? Is that, do I have enough information to count the time from here to here? The answer is no. You don't have enough information. What else do you need? You understand what I'm saying? So if you have this count here and you have this count, it's not enough information. What else do you need? I need to count how many overflow happened by the timer. Okay, remember, I told you before, here there is interrupt. I didn't use it before. This is the first time I use it, okay? But I told you before, every time the timer moves from ARR to 0, there is what we call overflow interrupt. So we're going to have overflow interrupt here. We have another overflow interrupt here. So now I'm going to have 2 overflow interrupts. Now, so all what I need now in order to calculate the time, I need 3 things, not 2. I need 3 things. Number 1, I need H1, which is the count. This is the time stamp for the first edge. Number 2, I need this one, H2. Is that okay? Number 3, I need to know how many times, how many overflow happened. Once you have the 3 information, I'm going to give you a small formula here, and I'm going to also explain the formula. I'm going to give you a small formula to calculate the time. Okay. So, okay. So, if you look at the 2 formulas, they're almost the same. If you see here, guys, every time there is an overflow, I have every overflow. Overflow means if it is a complete overflow, complete means you count from here to here. Okay, this is over. That means you counted ARR plus 1. So here, every overflow you have to multiply but by ARR plus 1. You understand what I'm saying? So, for example, if you start, yeah. So. Yeah, so here I started from 50, and here this is a complete overflow. So from here to here, it has to be should be counted ARR plus 1. So now that's what, so I want to choose a formula here, but there is a small difference. I'm going to tell you why we have a small difference. I'm going to tell you why. But keep in mind, every time we have overflow, it means you count it from 0 until ARR, and then you are gonna. It's going to take also another one. That's why we add 1 here. It's going to take 1 count to move to 0 here. Okay. So anyway, so every time we have 1 overflow, that means it's counted ARR plus 1. Okay. However, there is a small trick here. What is a small trick? Listen to me. Here we have 2 cases. One case, if H2 is greater than H1. Okay, this is the first case. So that means I started from the count was here. This is, we start from 0, 0 until ARR. After ARR, we're going to go to 0, 0 again. Okay, so see what I did here. So I start the first edge came here. Okay, guys, and the second edge was here. Okay, if H2 is greater than H1. The second case is if I start from here and then you are going to come here, trigger overflow, and then it's going to come back to here. This is the second case. How these 2 cases are different? They are different. Why? I'm going to tell you why. Look here. What is the problem? The problem here is the following. Listen to me, guys. I told you every overflow, it means the timer counted ARR plus 1 times every 1 overflow. However, this is not always the case. For example, if you look at this case here, guys, if I start from here, I'm going to start from this number. Increment. Here there is an overflow, and then I'm going to come here, stop here. I'm going to stop here. So I did not make a complete round. You got what I'm saying? Because it started from here, because H1 was greater than H2, I'm going to start from here. Trigger interrupt here. So this interrupt should not be counted ARR plus 1. You got what I'm saying? So it has to be the first overflow. But if there are other overflows, so for example, look here, guys. I start from here. So the first overflow, I'm going to trigger overflow, and then I'm going to come here. Is that okay? So this is first overflow. It should not be, you did not count completely. Okay? But just it happens that you start from a big number and then trigger overflow. Okay? But any other overflows, the problem usually in the first overflow. The first overflow, is that a complete or not? The other ones are going to be complete. What this means? I'm going to tell you what it means. Okay? It means this is, so the first overflow can be fake, can be complete or not, the first one. But starting from the second one, it has to be complete. Okay? So once I come here, I can make another round. Okay, trigger. So every interrupt after that should be ARR plus 1. Okay, so what? So how this is different? I'm going to tell you how. Look here, guys. As you see here in the, what happens is that here you start from H1 and you end at H2. Okay, so I started here and I ended here. Okay, so that's why you see the formula here. I need to get the difference from here to here, plus every overflow here should be multiplied by ARR plus 1. Because every time, because I started here, I started from here. Okay, so that means if I come here, so you already made a complete counting. That's why it has to be this way. However, here, the problem is here. Here, if I start from here and then come here and then I stop here, this overflow should not, the first overflow should not be counted because it's not a complete round. So what you have to do is that, okay, the first overflow, I'm going to take it, but I'm going to subtract this part from the first overflow. So what I did here, the first overflow, I'm going to multiply by ARR plus 1, but here, because you did not count completely from 0 until ARR plus 1, okay, from here, you count it until here, okay, that's why I'm going to subtract H1 minus H. Anyway, I don't think about it. I don't want to spend more time on this one. So the conclusion is, listen to me. So the conclusion is that, guys, the program I have just explained right now, I'm going to use the same program. However, I'm going to do 2 modifications to the program I have just explained right now. The first modification is I need to count how many overflows we have. That's number 1. Okay. So every time there is an interrupt coming from overflow, so I'm going to increment overflow. So I need to know how many overflow interrupts are generated. This number 1. That's easy. Just a variable. Every time I have overflow interrupt, increment is a variable. That's it. That's number 1. Number 2, if I want to measure time, I have to wait for 2 interrupts. I need 2 interrupts. 1 interrupt here and 1 interrupt here. Is that right? In this interrupt, I'm gonna save CCR somewhere. That's it. Here I'm gonna save CCR in H1. H1 is just a variable, okay? For this one. Here I'm gonna save CCR in H2. That's it. So as you will see right now. So if you look at the program here, guys, so the program here, it is, I'm going to use the same function I explained to before, that for the initialization, there is no difference. I'm going to explain, it's exactly the same thing. The modification will be in the interrupt subroutine. Okay. So let's see here in the interrupt subroutine. Remember, as I told you before, this, as I said before, this handler or this subroutine is going to be called for the same subroutine shared between 4 sources. Okay, channel 1 to channel 4. Okay, or sorry, this one has only 2 channels, 22. Okay, so channel 1 and channel 2, and also timer overflow. Okay, that's why when you come here, you need to check this register. Okay, so here in the very beginning, I need to check, is this interrupt because input capture? Yes, just to come here. Or this interrupt because timer overflow. Okay, guys. So what I'm saying here, because these 2 different events are sharing the same subroutine. When you come here, the interrupt subroutine, you need to check this bit, status bit. Okay, to know if this is for overflow or this one for input capture. Okay, so as you see here, if this is for overflow, all what I'm going to do, as you see here, guys, just increment a variable called to overflow. That's it. Because I want to count how many overflows we have. I want to count how many overflows we have, as you see. Okay. Also, now if I come here, if I come here, guys, that means we have, so every time there is a timer overflow, I'm going to come here to increment overflows. Okay, so this is number one. Number two, when I come here, so if I want to measure the time from here to here, so I'm going to have one interrupt here and the second interrupt here. Is that okay? Okay, so I need to know if this is interrupt number one or interrupt number two. Okay, because if this is interrupt number one, CCR, I'm going to store it in H1. If it's interrupt number two, is CCR, I'm going to store it in H2. Okay, that's exactly what it is. As you see, look here, guys. I'm going to have a variable. This variable is called interrupt number. Okay, as you see here, I'm going to increment the interrupt number. Initially, I make it 0. Now I increment it. So now, if you are interrupt is the first interrupt, I'm going to come here. If not, if the second interrupt, I'm going to come here. Okay. So in the first interrupt, as you see here, guys, what I'm going to do in the first interrupt, I'm going to store CCR in H1. In the second interrupt, I'm going to store CCR in H2. But there is some tricks in the middle. What are the tricks? I'm going to tell you what are the tricks. Look here, guys. For timer overflow, initially, I want to count how many overflow happened from here to here. Keep in mind, the timer, the counter is always working, and it can trigger timer overflows. You got what I'm saying? That means I should not, if there is overflow here or overflow, it should not be counted. I want to start counting from here, the overflows. You got what I'm saying? That is why I have to make sure the timer overflow interrupts initially are disabled. And here, once I come to here in H1, I'm going to enable timer overflows to here because I want to start from it. So in the first H, what I'm going to do, as you see here, I'm going to put 0 overflows because I'm going to start counting overflows from here, from the first, after the first H. I'm going to start counting, and then I'm going to enable the timer interrupts. Okay. If you forget to do that, what's going to happen is that this one is going to be incremented even before the first edge comes. You got what I'm saying? So even before the first edge comes, there may be some interrupts here, and then you are going to increment overflows. You are going to get wrong results. Okay. Anyway, so this is one thing. The other thing also you have to make sure of, and this is also very tricky part. I personally made a mistake in the beginning when I virtual long time ago when I first programmed it. Very tricky part. Okay. What is the tricky part? I'm going to tell you. Look here, guys. Before the signal comes, okay, maybe there are some overflows here. Okay, I don't want to count them. Okay, you are not going to count them because you are disabling interrupts. You are not going to come here. You are not counting them. Okay. However, there may be a request for interrupt, because there may be here request when you raise your hand, request for interrupt. So once you enable the timer overflow, it's going to be interrupted right away because of the history. There was an old request. Okay, I personally made this mistake. Okay, the mistake I made is that I noticed I got wrong. Always the overflow I get is one move. Always one move. I'm expecting 2 overflow, I get 3. I'm expecting 3, I get 4. Why? Because I forgot to cancel the history. What happened? Once I enable the timer, overflow is going to happen right away because of the history. Because you got to say that is why what I did here. You have to make sure you have to clear the history. Okay, so I have to clear. This is the bit for the timer, so I have to put 0 here. Okay, just in case there is a old request. Okay, so anyway, so one tricky part here, guys. So what I'm saying is that here in the first one here, I have to do I have to enable interrupts. I have to clear the history. Okay, that's number one. Number two, here you have to disable the timer. Here you have to disable the timer. Otherwise, the timer is going to be continue working and it's going to change the overflow here. By the time you do the calculation, maybe there are one or two more overflows. You can have same. That's exactly what it is. So here, very simple. Here's the interrupt timer. I'm going to enable it here. I'm going to disable it here. Okay. And then, okay, where you are going to do the calculation. Okay. So, and also, as you see here, guys, also I'm going to disable input capture. Also, I'm going to disable the timer overflow after the second one. Again, if you forget it, what's going to happen is that maybe after this one, then maybe another interrupt, and then you're gonna come here to do some calculations or whatever. So I just want to make sure every time I want to do calculation, I should have only two interrupts, one here and one here. Okay, that's why by the second one, I'm gonna disable input capture. Also, I'm gonna disable the timer interrupts, so that I don't want them to like change the number I already calculate. I already gathered. I gathered the number H1, I collect H2 and have overflow. Anyway, so let's see in the main program, how can you do it in the main program? Very simple. Look here in the main program, guys, what I'm gonna do. In the main program, every time you wanna measure, okay, number one, in interrupt number, I'm gonna start with 0. This is like initialization. Look here, you have while, because it's just continuous. By the way, before I tell you, this program is very interesting. What I did here in this program, by the way, guys, I forgot to tell you what I did here. I used one pin, which is PB0, to generate a signal using pulse width modulation. All what I did, I used the old program I explained to before. Okay, guys. So very interesting this program. Number one, I'm going to use pulse width modulation to generate a signal. So this number one. Number two, I'm going to use input capture to measure the signal I generated. Okay, and I'm going to display it on the LCD. Why it's interesting? Interesting because I am the one who generates the signal, so I know how big are the numbers. Okay, so now I generate the signal, I measure it, and I can verify if it's correct or not, because I'm going to see what I measure is equal to what I'm expecting or not. Okay, guys? Anyway, so that's exactly what I did here. So here, I'm going to call this one. One pin is going to generate a signal like this one. One pin is going to be input capture, which is BS6. You need to connect external wire. Don't forget it. Otherwise, it's not going to work, right? One pin is going to generate signal. One pin is going to measure. You have to connect external wire between BB0 and between BS6. Okay. This program is going to continuously measure. It's going to display the measurement on the LCD. And also I was playing. So here, because this is pulse width modulation, you can simply change it. You can change. I tried different values to change the frequency and measure and or change the duty cycle and measure and see if the measurement is correct or not. You understand what I'm saying, guys? So again, very interesting program. I'm sure it's working. You have this program I generate the signal on one pin and use the other pin to measure the signal I generated, and I display it with the LCD. Okay, so I want you to play with it. Just change. You can change the signal you generated, and you will see the number when the LCD is correct or not. Okay, very interesting. But anyway, so yeah. So here, as you see here, I'm doing periodic, continuous measure. I'm gonna, because you have while one here. Remember this one. So here I start the measurement. From here to here, I do the measurement. After you did the measurement from here to here, I'm going to display to the LCD. And then I go back again, measure, display. Go back again, measure, display, measure, display, and so on. Okay. So what I did here, in order to measure, number one, interrupt number is equal to 0. Okay. Number two, I'm going to here remove any bending history. This one for input capture. So I'm going to remove the history of any. Otherwise, if I forget this one, maybe once the first edge, you are going to trigger interrupt right away. Okay. So here I remove the history of input capture, and then I'm going to enable input capture. So now input capture is enabled. Timer is not enabled. Input capture is enabled, okay? And then here I'm gonna wait for 2 interrupts. I'm gonna wait until this variable is equal to 2. Remember this variable here, I increment it here. You got what I'm saying? So number 1, I enable input capture. Then I'm gonna wait until measurement is done. When do you know the measurement is done? When there are 2 interrupts. You got what I'm saying? So that's exactly what I. So here I have to wait. I have to wait for 2 interrupts here. Is that okay? After 2 interrupts, now just to do the calculation. So now interrupt 1 is going to give you H1. Interrupt 2 is going to give you H2, which is just a variable. Okay. Also overflow. So now you have H1, H2 overflow. All what you have to do just to compute the period this way. You can compute the period similar to what I explained here. You can use the formula you have here to calculate the period. Yeah, so you can use this one or this one. Okay, so that's exactly what I do. After you calculate it, after you calculated the period, as we did before, I'm gonna measure. For sure, I'm not gonna explain how can you measure. That's very simple, right? So just divide by 10, and then use right to LCD. Then I'm gonna wait one second and go back to repeat again. Any questions? I'm gonna repeat the tricky part. The tricky part is that initially input capture is disabled. Input capture is not capturing anything. Okay, every time I want to do measurement, I'm gonna start it from here. Okay? I'm gonna enable input capture, but before I enable input capture, I have to make sure the history. There is no requests, all the requests. I have to cancel all the requests. Also, I have to put here in this variable 0. And then I'm gonna wait until input capture is set to two edges. I have to wait. Okay. After you set to 2 edges, so now you have H1, you have H2, and you have overflow. Who made H1? This is the input capture interrupt subroutine in the first interrupt. Who made H2? This is the input capture interrupt subroutine in the second interrupt. And the overflow is going to be set by the timer overflows. Once you have all of them this way, you can just do the calculation here. Again, that's why if you forget to disable input capture or disable the timer in the second interrupt, maybe when you do the calculation here, overflow is going to change. Maybe that's why I have to make sure it is disabled. Any questions? Okay. The last thing I'm going to teach here, guys, is okay. So what I did right now is this program, I measured, I captured, I want to measure the time from here to here. So I'm going to capture rising edges. Okay. By the way, you can capture falling edges if you want. So it's going to get the same thing. So if you want to capture, it's going to be the same thing because usually the time from here to here is equal to the time from here to here. So you can capture also falling edges. Okay. I just made it rising edges. Okay. Now, and this may be the important part. Now, what if I want to measure? What if I want to measure the time from here to here? Okay. What can I do? Okay. So it's not a new program, just the same program, but I'm going to modify it a little bit. Okay. Very naive idea. Even myself, I made a mistake in the very beginning long time ago. Anyway, so very naive thing you can do. Someone can say, okay, that's easy. And instead of capturing only rising, I'm going to capture both rising and falling. That's it. So that I'm going to have one here and I have another one here. Everything else is the same. Just to change the initialization from capture rising to capture both rising and falling. So answer is no. When I did it by myself, I found sometimes it's correct, sometimes it's not correct. You know why? I'm going to tell you why. Simply because it depends on where you are going to start measurement. So if I start from here, measurement, so actually I'm going to measure the time from here to here. Okay. But if you start from here, it's going to be correct. You are going to measure the time from here to here. You got what I'm saying? So I found just to be on the always work, okay, to make it always work, also to be on the safe side, I'm going to do it this way. Look here, guys. Number one, initially, I want to capture rising. So initially, I'm going to wait for rising. In the first interrupt, I'm going to change the initialization. I'm going to tell the input capture, now you need to capture falling. You got what I'm saying? So I have to make sure the first one should be at rising. The second one, it has to be at falling. So how can you modify this program? Okay, in this program, in the initialization, the first one was rising, so I don't need to do anything. All what I did here, guys, is that in the interrupt subroutine, I just added this part in the interrupt subroutine. What I did, after I receive the first edge, after I get the first edge, I'm gonna change the configuration. I'm gonna tell input capture. So initially, I'm capturing rising. Once I capture one rising, I'm gonna come here. Now I'm gonna change it to capture falling. That I'm saying. So I'm gonna change the configuration so that next one is gonna be at falling. Okay. Everything else is the same in the program. But there's also here in the main, you have to add this one also. Okay, in the main. I have, because I changed the configuration to falling. So when every time I wanna do measurement, initially I'm capturing rising initially. Is that okay? After the first interrupt, I'm gonna change it to capture falling. Okay, guys? Any questions? Again, you have the programs. I'm sure they are working. So run them. Okay, especially this one was really, I personally enjoyed it when I did it. Okay, but why? I'm the one who generated the signal. I'm the one who measuring it, and I was just playing. So okay, now it changed because this is pulse width modulation. So when you change the CCR, you are gonna simply change the time from here to here. Is that okay? It was very accurate. Never had any mistakes, even in one count. It was very accurate. Okay, it was really good. So the time, in the pulse width modulation, I'm expecting, for example, 500 counts. When I look at what I measured, it was 500, and so on. You got what I'm saying? Anyway. Okay, thanks, guys. Any questions? So as I said in my email, for the final exam, it's gonna be, we're gonna meet on Monday, right? I sent you the time, 3:30. I guess it's gonna be in the same room here. So this exam will be similar to what we did before. It's gonna be open book, so you can use your slides, and it's not gonna have assembly. So there is no chapter 1 or 2. So it's gonna be starting from chapter 3, 4, 5. I didn't think about it so far, but usually what I do, I give you some kind of application. Okay, so someone can ask me, okay, if I want to prepare for it, how can I prepare for it? Okay, for sure, I'm not the kind, maybe you already heard something about me. Okay, I'm not kind of a professor who wanna challenges the students too much. Okay, I just want to make sure you understood what I explained. That's it. So if you did all the labs by yourself, if you did the project if you did everything by yourself in this course, you should be fine in the final exam. Okay, so in the final exam, again, I didn't think about it, but the way I usually do it is it's going to be some kind of application. Okay, for example, you should know how can you use the LCD. You should know how can we use the keypad. You know how to make interrupts. You get what I'm saying? If you know all of that, okay, just I'm going to give you application, maybe similar to the project you have, but for sure I'm going to consider the time. Okay, that's it. Once you don't need to memorize anything. You get what I'm saying? So there will be no surprise, nothing new. What if you understand labs, if you understand what I explained here, the slides, you should be fine. Okay, I'm not going to bring something I didn't teach, I promise. Okay, guys. Any questions? But honestly, because it's open book as well, I have to make some kind of balance. Okay, so don't think. So open book, so maybe there may be some challenges at time. I have to challenge somehow, right? Again, maybe I challenge you a little bit on the time because you already have the slide. You got what I'm saying? But it's gonna, if you already know how to program everything, I already chapter 5 is gonna be included. Okay. You already have the programs here, just to understand it. Okay. Any questions?